Hey everyone, I'm Max. Welcome to the channel. This is my first video on here. I thought it would be really helpful to go through and talk about my process for designing custom cabinets, both from the laying out in like a CAD tool to turning it into a cut list that I then go and rip down a bunch of plywood and build custom cabinets. So I'm a hobbyist DIYer, not a professional. I picked up this, I guess, hobby a year ago, and I've learned so much since then. I basically have consumed every single video on YouTube about building cabinets. On Instagram, there's a lot of creators on there too, and I just love doing it. I think it's so fun to be able to build something real that's functional, that uses high quality materials because it feels like that's becoming harder and harder to get every single day, and being able to build truly custom cabinets for a space. And to me, doing it in a tool like Fusion 360, which is a CAD tool, lets you completely design kind of a pixel perfect cabinet, if you will, exactly to the dimensions of the space. So over the last year, I've been building so many cabinets, little projects from vanities to I just got done with a closet for my office that I will be doing a video on soon. And I thought it'd be helpful to walk through my process of designing the cabinet, drawing it out, doing renders, and then converting that over into actual cut lists that you can then use to rip down plywood and assemble boxes and things like that. So this is also going to double maybe as a little bit of a Fusion 360 tutorial, and hopefully this will be helpful to some of you. I think everyone's got a different workflow. Maybe mine will work for you, maybe it won't, but anyways, just to kind of show you what's possible. This is something that I have been working on over the last few months, and I guess I shouldn't say a few months. It took me a day or two to actually put this design together. This is going to be for a kind of a new nook in our kitchen. We're going to take out an old like writing desk. People don't really use those anymore. And put in upper cabinets, drawers, a drink fridge, and then I've been seeing a lot of people doing these like dog bowls, and so we kind of were thinking about doing that. We're not sold on that yet, but just to kind of show you what's possible, you can end up building these custom cabinets and doing renders and seeing the space. And I designed this completely to fit into the space. So I went down to this area, brought my measuring tape, measured every single dimension, considered where the door casing was, how much distance we wanted from the edge here, the countertop. And then I took all these constraints, these variables, brought them into Fusion 360, and I designed around them. And I'm going to walk through this, so don't worry about it. But I was able to go and take every measurement of the space, like how wide the wall is, how tall the room is, the depth. I don't remember what that was for, but how big the fridge is. I went and looked at some fridges, and I found a Sub-Zero one, and I looked at the spec sheet and took the exact measurements. And so by doing this, I can then go and build a custom cabinet or set of cabinets that fits perfectly to the space. And like I said, I just did this with a closet, and it was an exact fit. And I had to make a few small changes along the way because things were a little closer than I liked with some of the door casing, whatever. But the point is, it was an exact fit, and everything that I accounted for, like the swing of the door and everything, was kind of, when I built it, it ended up being the same. And that's really amazing. It's worth learning a tool like this. So I like Fusion 360 because it's free. They have a free tier. You can have 10 active projects, I think, at once that are in edit mode, but you can basically have as many as you want. You can see I've got so many here, and you just put them into read-only mode, and then you kind of switch between. And it's used professionally in industry. I would say the professional cabinet shops are probably using a tool like Mosaic. So I don't think they're necessarily doing this. Maybe smaller scale ones are. It's Mosaic, I think, is really expensive, and it's very feel like if you're pumping out a lot of projects or using CNC machines, it's a better tool. But for us homeowners, DIYers, just enthusiasts, I think learning a tool like Fusion 360 or something like Sketch, which if you want to use that, that's cool. But I think it's a great tool. I don't always start here. Sometimes I go and I use a tool called Home Designer, which I really can't recommend anymore because they messed up their pricing. But Home Designer is like a layout tool, floor plan tool that has a lot of building blocks. Like you can quickly put in cabinets, you can put in appliances. They have like Sub-Zero catalog, LG, all these building blocks, which is really nice. But it's not as pixel perfect. I'm not going to go in there and design a fully custom cabinet. I'm just going to say, okay, here's a base cabinet. Just visualize. It's more for that and for doing like floor plans and like electrical plans and things like that. But again, I can't recommend that tool anymore because the pricing is ridiculous and they basically broke it for DIYers. So I basically jump right now. I feel proficient enough where I start in Fusion 360. So enough with the intro. Let's talk about how I would design a small base cabinet with like 3 drawers. And I'm going to talk to you about how to think about using Fusion 360 and how to like start. And so basically, step 1, always before you design something, is go take a bunch of measurements. Measure how wide the wall is, measure how tall the ceiling is, account for everything in the room, and then come into your project, start a new design, and go up here. And this is where I start every project. I go into the Modify tab here and I go to Change Parameters. And what I'm doing here is I'm going to build a cabinet that's completely based on the constraints and the variables in the environment. And so usually the first thing I do is I set my wall width and then the dimensions of the wall that a project is going to go up, assuming it's like a installed project. Before I get into that, just make sure you have the unit set to what you like when you're building cabinets. A lot of people here are going to want inches in America. I will encourage you to make the switch to metric. It will make your life so much easier. Trust me, it's so much easier. I think if you are, a gray beard or what have you at this point, you probably are using inches in America and you're not ever going to change. That's fine. If you're starting fresh, start with metric. Trust me, it will make your life so much easier. You're going to be doing a lot of cabinet design that's following like a Euro standard. Metric is what you want. So I'm going to do metric, but you can change it how you want here. So I measured, and I'll show you can still use inches. So we go into change parameters, and we're going to define like the parameters of the room. And I've got this microphone in front of me that's kind of annoying, but I'll try to type around it. So usually I start with my wall width or wall height. Let's start with wall height. And I'm going to say it's 96 inches because they're 8-foot ceilings. That comes out to metric millimeters here. I'm going to say wall width. Let's say this is like, I don't know, an 8-foot wall. Again, I'm using inches, but under the hood, we're using metric. So now I've got my first wall. I usually just like to draw the wall out. And so create a sketch on this plane here. And I'm not really being particular about what plane. It's kind of just like whatever plane I pick, that's how I start my drawing. So wall height, wall width as the 2 constraints. And so now you can see here, my walls aren't going to change, but now they're defined by that parameter I set, which is really nice. Usually when I do walls, it's just to help me kind of visualize. So I finish the sketch, I extrude it, and I'm just going to go like -2 inches. I'm so inches brain when it comes to this stuff, but that just gives me like a solid surface I can kind of visualize my cabinet against and gives me a plane to draw future cabinets against. So now I'm going to start with my actual cabinet box, and I'm going to do this in a way that is actually based on the material that I'm using, because I want this to be pixel perfect. And so the only way it can be that is if I'm correctly accounting for my material size, width. In this case, most 3/4 inch plywood in America is about 18 millimeters or 19 millimeters. I've found that the standard stuff like birch, cabinet grade material, pre-finished birch, it's 18 millimeters. If you get something like a hardwood veneer, like a walnut, higher end expensive stuff, the stuff I've bought recently has been 19 millimeters. And so, just pick, and if you're using half inch, or 12 millimeters, 13 millimeters, you based on the thickness of your material. So go measure it, put it in here. So 18 millimeter, and I'm going to call this ply thick. So this is the thickness of my plywood. So there's some kind of cabinet building experience you need to have before you go and build this box. But if you think about a box, it's just 4 sides. So I usually like to do it where the bottom and the top are kind of inside the sides if it's going to be fixed in place, because there's less edge banding you need to think about. You're not going to have these 2 edge pieces sticking out on the sides that you have to deal with. However, if I'm doing like a rolling storage cabinet, I like to do it the other way, where the sides are inside the bottom, so that the sides, all the force of the cabinet is going down into a flat base, not a shear force between the bottom and the side pieces. I know that's confusing, but okay. So we're going to do what I usually like to do, if the cabinet's going to have a countertop, I like to think about starting with the countertop height and working backwards from that. And so generally, I think in America, countertops are usually 36 inches high, let's call it. And so if you account for that as kind of your countertop height, then everything you do can be kind of subtracted from that, if you will. So we're going to do a countertop that's 36 high. So that will be the very top of the cabinet with the countertop. Generally, countertops are call it 2 or 3 centimeters. And so we're going to do countertop thick. I'm going to call it 3 centimeters for the countertop. And then you're going to want a toe kick at the bottom of the cabinet. This is just like a kitchen cabinet. There's a lot of different cabinets you can build, but I'm just trying to give one example of common type of cabinet you're going to build, like a kitchen-based cabinet. So for toe kicks, toe kick height, I'll do 100 millimeters. I think generally it's like 4 inches, which is about 101 millimeters. So let's call it 100 millimeters. I think that's easy. And then the cabinet height is going to be the counter height, which again, remember 36 inches or 914.4 millimeters, minus the toe kick height, minus the countertop thickness. And so the cabinet that we build is going to fit perfectly within the height that we have available to us. And so that's like a good way to think about how to design a custom cabinet like this, is think about the constraints and then divide, subtract what you know, and then the space you're left with is how you're going to fit your cabinet in there. Okay, so we've got a bunch of constraints here. So I'm trying to think about what I'm missing. Okay, so I think for the cabinet width, I'm just going to throw 1,000 millimeters in here. I don't really, it's kind of just like a standard width, but all right. So now that we have the constraints set up, we can start to draw that first cabinet. So I'm going to go and create a new sketch. I'm going to do it on the wall as the plane. And I'm going to start with the toe kick. So I'm going to create a rectangle, drag it out. I'm going to do toe kick height. I'm going to do cab width here. See, we got a toe kick spot here. And then I'm going to create the first 2 side pieces of the cabinet box. And so we have cab height, because those 2 side pieces are going to fit. They're going to go fully from the bottom of the toe kick to the top of the bottom of the countertop. So we can fill that whole space. We'll do cab height and then ply thickness. And we're going to do another one on the other edge here. So we've got the two side pieces to the cabinet, and then we're going to do a bottom piece, which is going to fit in there. So we're going to select this corner there, this point, I should say. We're going to set the width of this or the thickness of it to ply thickness, and then we're going to drag it over to be constraint on that point there. So that should be, so usually when you build a cabinet box, depending on how you want to do it, you do a solid base on the bottom, solid pieces on the sides, and then what are called stretchers across that are not as wide, and I'll show you that in a second. They are just to give the box strength, rigidity, and actually make it a box. So I'll show you that in a second. And I'm going to add this as a constraint, which is the stretcher width. Usually I just do 100 millimeters, and I'll show you that in a second. And so we're going to go and start to extrude the pieces for this cabinet box. So the sides, I'm going to select that rectangle, and I'm going to select the other rectangle, and I'm going to extrude it to, I guess I didn't do cabinet depth. We're going to do cabinet depth first. What's the standard cabinet depth? Okay, 600 millimeters is a good standard cabinet depth. I'm going to select these two sides, extrude it out to the cabinet depth. And notice here we've got a join. We do not want that. Anytime you're doing cabinets, you want these pieces to be individual bodies. Always choose new body. And so now you can see we've got these sticking out. Of course, the first time you do extrude of a sketch, it automatically hides your old sketch. Wonderful feature. So you got to go back to sketches and show that again. All right, then we're going to do the same thing on the bottom. Extrude that to the cabinet depth, new body. And then I'm going to extrude this stretcher, and I'm going to choose stretcher width. So we've got one stretcher going along the back. We're going to add another one in a second here. All right, so we need to do a little more work on this toe kick here. So I'm going to go and open up this sketch again. And depending on how you want to design the toe kick, I think we could do two side pieces. So I'm going to draw out two small side pieces for the toe kick. Set them to the right height. And then I'm going to do something slightly different with this. I need to also set my toe kick kind of inset, I guess, like how far deep the toe kick goes. I think a standard is 3 inches in America. So we'll call that like 75. So we're going to extrude these out to the cabinet depth minus the toe kick inset. Again, make sure we're doing a new body here. Do it again on this other side. Cabinet depth minus toe kick inset. And actually, I'm going to do toe kick inset minus another ply thickness, because I'm going to do a piece of plywood across the full bottom so you don't see these edges. So I'm going to edit this other extrusion I just did. Really nice feature in Fusion 360. Just go and edit the feature. If you're new to Fusion 360, this is not a beginner tutorial. This is kind of just like a semi-beginner tutorial, I guess. Learn by doing tutorial, which is how I learned. I just started messing around with it, building cabinets. The way Fusion 360 works is it takes all these operations and applies them basically every time there's a change in the file. And so it's walking through and applying every single one of these features, if you will, down here in the timeline to the current design. And so we can go back in history, say edit feature, and change some of these values. So I want to subtract one more ply thickness from that, and we're good. So you can see the toe kick side pieces come out a little bit. We're going to create a new sketch on top of this here, and we're going to project this other piece so that we can use it in our sketch. So P is to project, lets you just project other geometries in the scene, I guess, and reference them so you can do constraints on them and things like that. So I just wanted to project this other piece here so we can go and draw a rectangle from that corner to this corner. Notice it snaps for me because it's been projected. This is going to be a piece of plywood in the front for the toe kick, and I'm going to select all those regions and extrude it out into a new body. That's going to be the front toe kick piece. This grid is getting a little annoying. Good. Okay, so you can see we've got this toe kick on the bottom. That's going to be basically the base of the cabinet. And we've got this cabinet box. We've got a stretcher. We need to add one more stretcher. So usually, I think this is for very minimalist cabinets. You're going to have two stretchers, and you're probably going to have a nailer, which I'll show in a second. So the stretchers go across the top. We're going to do one more by doing a sketch on the inside of this one other cabinet side. And I'm going to go and hide this other body so we can see this piece. And actually, while I'm doing that, this is a good time to go and name my bodies. So you can call that wall. I call that cab left, cab right, cab bottom, stretcher 1, toe left, toe right, toe front. So I'm going to open the sketch again. I'm already in it. And then I'm going to hide the cab left body so that I can work on this object. I'm going to draw that other stretcher. Again, remember the stretchers are always the thickness of our plywood, and then what we set for the stretcher width. Okay, and then show that cab left again. I'm going to select this region. I'm going to extrude it. And sometimes if I'm being lazy, I don't put in a value here. I just click the other side, and it's going to go to that distance. And we've got our two stretchers here. And I'm going to kind of do a similar thing for the nailer in the back. That just gives us a way to secure it to the wall. You can do one or two nailers, I guess, just depending on how secure this needs to be for you. I'm going to do two nailers. I'm going to go here. I probably have to do some projection so I can get a nice corner to work off there, and then one on the bottom and project this. I'm going to use the same stretcher width value, ply thickness, do one on the bottom too. It's got these two nailers, and we can go to extrude those. I'm going to show that left cabinet again. Hit E to extrude. Select that other one. Again, make sure go to new body. So created two new bodies here. Okay, so we've got the base cabinet done here. I'm just going to hide the wall. It's getting in the way. Look at our beautiful cabinet that we just designed. So we could go and make this right now. And I think maybe let's just do that first before I show you how to do drawers and things like that. So I like to use a tool called Cut List Optimizer. And what Cut List Optimizer is, it's basically a tool that helps you take your material that you have on hand. So for example, an 8x4 sheet of plywood, and then define your panels. The panels being the pieces here that we're going to cut out of those sheets. And then it will tell you what pieces you should cut in what order and how they will fit on the sheets that you have on hand. And so the first step you and I pay for this. It's a monthly subscription. They do have a free version. I forget what the limitations are, but I use it all the time, so I just pay for it. Happy to support them. There are other tools out there if you want to find something free. There definitely are. I've used some other ones. I think I've just gotten so used to this now. I just like the way it works. So I like the way it looks with the cutlass. They're nice and clean. Okay, so once you pick up a sheet of plywood from your supplier, you need to come in and measure it and put in the actual sizes here. So I think a standard size, I kind of was looking on a standard size about 24 40 millimeters by 12 20 millimeters. Again, I think they're always a little bit different. Mine have always been a little bit different, but this is where metric helps because a lot of them are defined in metric actually, not in imperial or inches. So, and certainly not, they're never going to be 8x4 exactly. So just always measure it exactly. And let's say I have one sheet of this stuff. I'm going to create a new material here. I'm just going to call it probably birch 18 mils. So this is my basic standard 3/4 inch plywood. And then what I do is I go in Fusion 360, and I think there are plugins out there and mods that can help you generate cut lists from your Fusion design. I've never used them. I don't even know if the free version has access to any of that stuff. So I'm just going to come in here and show you what I do manually. But basically, I use the measure tool, which is the I shortcut. And I come in here and I say, okay, these side panels are 600 millimeters wide by 784.4 millimeters tall. I've got two of those, and these are the 3/4 inch birch. My bottom piece is 964 by 600. I've got one of those. My stretchers are 964 by 100, and I have 1, 2, 3, 4 of those. That's why it's nice to just use the same size, because then it's easy. So I've got my two panels here. I've got the bottom, I got the stretchers, and then I got this toe kick here. So the sides of the toe kick, 507 long by 100 high. I've got two of those. The front is 1000 by 100. Got one of those. I guess I didn't do a back piece. You don't need one probably. It's plenty strong, but if you want to add one, you'd have another there. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. 6, 8, 9, 10. Cool. So it looks like we've got all of our panels here. A couple of the other options you want to look into before you do this. You can have the settings on your project. There's some other settings here. I usually don't mess with them, but the units, I've set this to millimeters. And then the other one you want to look at is your cut / blade / curve thickness. So you could make this the exact size, the kerf, basically the width of your saw blade, if you want zero waste with your cuts. I think the track saw I use has a 1.8 millimeter kerf blade. That's a Festool. That's kind of the size they've gone to now. I usually just do like 3 because it gives me a little more buffer. And then if I don't know, make a mistake or something, I'm not like cutting it too close. Okay, so now that we've got that all set, we're going to go to calculate. And we see that we have this really nice cut list for this sheet of plywood that we have. So if I have one sheet of plywood, I'm going to take this, I'm going to go to export to PDF and get a really nice PDF that I can print and take out to the garage, wherever I'm working, use this to cut down the sheet. So if you look here, I don't usually follow this exactly because everyone's got a different workflow, but it's showing you the different order of the cuts that you could follow to do this exactly. Generally, I like to do my rip cuts first, now that I have the tooling for it. Before, I usually would do my cross cuts. But if you see here, we've got this line here where these are, this side here and this side are the same width. And so let me see if I can change this to prefer cuts along the width and see how that's different. Yeah, so I don't really follow the path here. I kind of just do what feels right. But this is prioritizing some of the rip cuts first. But it's a little weird to me. I don't really love that. But anyways, you can change it based on what's easier for you. So okay, so that's how you build a basic design and build a basic cabinet box in Fusion 360. I want to show you one other thing which gets into using patterns. So if you had a drawer, a set of drawers, and you wanted to repeat the design multiple times, I'm going to show you how I do that. So let's say we want to do 3 drawers in this. I'm going to go and define that as a parameter. I'm going to say num drawers. And for this, I'm going to say no units because it's not a unit. It's a unitless number. It's 3. There's no unit. And I'm going to do inset drawers, and a standard inset gap is 3 millimeters. Now we can do some math here to think, okay, we've got, we want to define the open space inside the cabinet. And so we go back here, we've got the bottom, we've got the stretch at the top. And so the open space that we have for the drawers is, we're going to call it the inside height. It is the cab height minus 2 times plywood ply thick. So because we've got a piece of plywood on the bottom here and at the top, we subtract it twice. And so the open space should be 748.4. Let's verify that. 748.4. And so our drawers, each drawer will be, so to figure out the height of each drawer front with the inset gaps accounted for, we need to do a little bit of math. And so this can be a little tricky. Honestly, there's no shame. Just go to AI, go to whatever tool you use, and figure out a formula here. And so Gemini gave me a formula to use to compute this. You take the opening height subtracted by the number of drawers plus 1 times the inset gap divided by the number of drawers. And so I'm going to try to convert this over into this formula here. So we've got the inside height minus the number of drawers plus 1 times the inset gap divide this by the number of drawers. And so each drawer should be 245. Drawer front should be 245 point whatever tall. And when you're going to cut this stuff, it's impossible to measure these fractional units. You can round down. It's not a big deal. You're missing 0.5 millimeter. You'll never notice it. So, all right. So now we kind of know the height of the drawer fronts. We need to actually lay them out here. So I'm going to create a new sketch, and I'm going to use the front of the box as the plane. Again, just before I do any of that, I'm going to project all these sides here so I have access to them. And this can be a little tricky. I'm going to try to do this in the way that I think I usually do it, and we'll see how well it works. So I'm going to create a line that is a construction line. So construction lines are very useful. They end up becoming things you can reference that aren't part of the, I don't really know what they are, but they're not really considered part of the normal sketch geometry. And so you can use them to help you draw objects and use them to be constrained to other objects, but they're more to help you build shapes, not to become shapes themselves, if that makes sense. So I like to start in the midpoint of the box and draw a sketch line that is the inset gap. And so you can see I've got this little 3mm line here. That's basically the inset gap where I'm going to start to draw my first drawer front. Usually then I go and I try to draw like a starting point over to the other side. And then I draw another one in that's also the inset gap. And so I'm trying to give myself a way to draw a rectangle here. That is the drawer front, using these gaps as a reference. And I'll do the same on the other side. I draw a line over to the other side. Draw another inset gap out. Okay, I'm going to go and draw one more line down because it's not giving me a reference there. And I'm going to do drawer height. And I'm going to do another drawer height. Make sure you got the 90-degree here. You're not doing any tilted lines. And then I'm going to draw a rectangle. This should work this time. Do these points. Okay. I know this is convoluted. There's probably an easier way to do it. Sometimes it's just an easier way for me to do it. So now I've got this rectangle here that I can repeat the number of times we have drawers. So there's two ways that you can do this. You can either repeat the sketch geometry while you're in the sketch. You do that, you go to create rectangular pattern, you select the edges, and then you can repeat it that way. Usually a better way to do it is to actually exit the sketch, design the first body for the drawer. And so I'm going to do that, show you. So I've got a drawer thickness. I'm just going to do the ply thickness here. Usually people do, I think sometimes smaller drawers, but whatever you have in terms of drawer material, that'll be the thickness that you use. So we'll do negative because I want it to go inside. Remember, this is inset. It's going to go inside the cabinet. This will be our drawer front. And so we've got drawer 1. And it's sitting in there nice and inset. We can see the gap around the edges, exactly the inset gap. That's looking good. So I want to repeat this body. And you imagine if I had something more involved here with like different edging around it and whatever you want to do, then you have a more complex body that you can repeat. But this is just a simple rectangle. So let's go and do create pattern. We're going to do a rectangular pattern using this body as the thing we want to duplicate. And then for the axis, we're going to choose any of these lines. I chose that one right next to it. So you can do whichever one you want. So the different distributions, I sometimes like to use spacing because then I can set the distance here based on the actual size of the drawer front, the height of the drawer front. And so because this is wanting to go up, I'm going to do negative drawer H, but I need to account for the inset gap. Okay, so let's see how that worked. Okay, that's perfect. So if we look back at the rectangular pattern again, I can see that I did make sure this is set to the number of drawers. And then I did spacing because it's a slightly different distribution algorithm. um, extent takes the full space. So if I did extent, then I would measure down to the bottom of the box and have it lay it out to fit the extent. I don't like that way of thinking as much. I like spacing, where I'm thinking about space this out based on the height of each drawer front. And so usually I use spacing. It's easier to think about. The distance that I did here is the negative, because I want to go down, the drawer height plus the inset gap. And so that will go down the height of the drawer plus the inset gap, leaving me with a really nice clean layout of drawers with that 3mm inset gap between each one, 3mm on the side. And now if I wanted to do something like 4 drawers, I could go into my parameters, change this, and everything should magically work. I've got 4 drawers. And so I can go and put this in my cut list. I know exactly how tall to make each one of these. It's really, really nice. And that's the benefit of doing this parametric design. If I come in here and change some of the values, in theory, the design should update pretty easily. In practice, it usually doesn't work out that way without having invested time in making sure your constraints are set up right. As I was building this, I noticed a few places where I didn't have appropriate constraints. And so if I change a value here, like the cab width to like 1500, it's probably going to break. A lot of it worked, but these stretchers clearly were not properly constrained to this edge. I think they were, when I got lazy and I did the extrude and I clicked on this, it just used that value, the distance. It didn't actually constrain it to the edge. So there's some work to do if you want it to be truly flexible based on changes there. For now, we don't need to do that. I can always go back and fix it. But yeah, so this is a basic cabinet design that I did in Fusion 360. I've got it in cut list here. I've got the cut list. I can print this out and then I can go and assemble it. And because I took appropriate measurements in the space, now I can say, okay, this should actually be correct based on the space that I have here. And I accounted for things like the countertop height. Remember, we did that in the beginning. We set the countertop height, 3cm countertop height, or 36-inch countertop height, 3cm counter thickness, and everything was kind of referenced off that to fit perfectly in the space. So again, when you go to build this, you're not always going to be able to properly account for some of these fractional units. Nothing wrong with rounding down. Your cuts are never going to be exact anyways. This just gives you a good ballpark for making sure that your design is actually correct and going to fit in the space that you have. All right, the first time I recorded this, I forgot a really important part that's super, super helpful, which is the drawing tool in Fusion 360. So once you have the cabinet design that you like, you've got the render here, and you want to actually turn it into a drawing. And the drawing is really useful because then you can go take your design and you can take a kind of a technical drawing to your space and then share with other people. So, my wife needs to see what I'm doing. Maybe you've got like a contractor you want to show something to, and then you can verify all the measurements are right. So what we do for that is I'm going to save this. And in my sidebar, where did that go? Okay, I'm going to right click on my design and I'm going to go to create drawing. That's going to pop up this sidebar here to have me specify some of the settings. Generally, you can just leave all that default. And then it's going to go and create a drawing, which is a different type of project inside Fusion. The drawing takes a reference project and lets you actually lay it out in 2 dimensions or 3 dimensions with like a perspective drawing. So to start, you place the base view, and then you can go and do projected views from this of different sides of the design. So I usually just click and I go in a circle, and then it's going to force you to have those perspectives. In this, I'm going to disable the wall for this project. You can go in here and tweak some of the bodies. Be careful with projects with a lot of bodies. The drawing tool can become super unresponsive. Each view here can be modified. So if I want to change the size, I can adjust the scale until it looks a little bit better. So 1 to 20 might be good. 1 to 15. I'll do 1 to 20. I can drag these around if I want to adjust the layout a little bit. In this, what you want to do is you want to use the dimension tool to draw dimensions. And unlike in this tool, in the actual designer tool, these dimensions are more informational. So they describe how wide something is. And so I've got this cabinet here. This is the side perspective. And I'm going to do a dimension. I hit the D key. But otherwise you click dimension here. I'm going to select these 2 points. And this is going to show me a dimension line that I can put on the drawing. So I'm going to go around, and all the dimensions that I think are important, I'm going to draw them here. And you'll notice these are all matching the numbers that we had in our parameters. I can do dimensions on the other views, but I can't do them on projected views. See, it's not letting me do a dimension here. Well, it sort of did, but I don't know how that works. Can you only do them on side and front? Not these they call it isometric projected views. You can only do them on orthogonal drawing views only, which are the front on, side on. And so whatever's helpful, I can do and draw these dimensions. And then when I print this out, I can then go and have something on hand to say, okay, make sure everything's right. And you can move these dimensions around so if they're kind of in the way. Really, really nice tool. I love the drawing tool. I use this all the time. If you're working with clients, this is probably a really important tool for you because the 3D view is nice. And you can even do the render view and start to get crazy by adding in different materials. And, let's say you want to show a painted cabinet that's, I don't know, blue or something. You can go in and actually have a rendered cabinet view and then adjust the lighting and do a nice render for a client. But it's easier probably to see when you're actually thinking about elevations and things like that. The drawing tools is really where it's at. So love to use this tool. It's very easy. When you're ready, hit print and print it to your printer, save it to PDF, whatever you want to do. Really great. Take this to the space, double check your measurements. A lot easier to look at than the... So this is my first video ever. I'm sure this tutorial is not going to be satisfying for some people. Please leave a comment below if you have any other questions. I'm happy to answer them. I'm just starting this out myself. I've only been doing this for a year. I'm new to cabinetry. I'm a DIYer. I'm an enthusiast. I'm not a professional. I've never done this work professionally. No one has ever paid me, nor should they, for building these things. I do it purely for myself. I've built probably 5 to 10 cabinets over the last year, everything from bathroom vanity to a custom closet, which was by far the biggest project that I did. And I'm going to do a whole video on that. 2 rolling storage boxes, which I'm also going to do videos on. And then I've done a bunch of other designs that I haven't actually built yet because they're kind of part of long-term projects. So I'm new to this. I'm still learning. If there's something I did wrong that I could do better, please let me know. And if you liked it, of course, I got to say, leave a like and subscribe. I want to do a lot more videos here. I think I've learned so much from people on YouTube who have basically given their time and taught me how to do this for free. It's amazing. I love building cabinets. Got so many things I want to build. And so if you want to see me make more videos, your support would be hugely appreciated. Thank you very much.